This triangle looks impossible at first. We only know one side and one angle, yet we are expected to find its area. Is there enough information in this diagram? Yes, there is. In the next few minutes, I will show you the one idea that turns this seemingly impossible problem into a surprising simple one. Let's get started. First, we'll write the solution. Solution. What we already know is that we have one side that is 12 units, and we have an angle at the vertex that is 30 degrees. And we are asked to find this area. The usual formula for area that we know is area equal to 1/2 multiplied by the base multiplied by the height. This is the formula that we are going to use to find this area. We know this formula already. But what we don't know is that here we have the base, which is 12. We have an angle here, which is 30 degrees, but we do not have the height. So we need to find the height. How do we do this? Let's redraw this triangle. We know that this is an isosceles triangle because of these two markings here, which shows that these two lines are equal. So the best way to find this area of this is to draw an altitude. That is a line from this vertex down to the base into two equal sides from here down to the base, where we have a 90 degrees here, a 90 degree here. So this line will create a line that is perpendicular to the base, and it cuts this base into two equal parts. Now we can see we have two triangles here, triangle 1, triangle 2. This whole side we know is 12 units. Now that it is divided into two equal parts, one side will be 6 and the other side will be 6. This angle here will be 15, and here will also be 15 degrees, 15 degrees. Here is the height that we are looking for. So if we decompose this shape into two different triangles, we'll just take one triangle, which we will now use to find the height. First, let's redraw this triangle. Okay, so this is still one part of that triangle. This is the perpendicular angle 90 degree that it formed. This side is 6. This is the height h that we are looking for. Half of the angle, because this 30 degrees was divided into 2, half of it will be 15 degrees. We'll use this information to get the height. From there, we will now substitute it into this formula to get our area. That's just what we need. Very easy. Every right angle, that's an angle that has 90 degrees. To find any of the missing sides, we use an acronym that will always help us to remember. Here we have the longer side is the hypotenuse. This is the adjacent line. This is the opposite line, the line facing the vertex angle. We'll use this acronym SOHCAHTOA to find any of the side or the angle of a right angle triangle, depending on what side or what angle you are given. If you have a side and a hypotenuse and you are asked to find an angle, you definitely use sine. If you have an adjacent and a hypotenuse, you will use cosine. And if you have an opposite and an adjacent, you will use tan. So we know that our sine, this represents our sine, which is any sine theta, which is what? Opposite over hypotenuse. This is where we use our cosine. If you have angle theta, which is equal to adjacent over the hypotenuse. The last is for tan. When you have an angle theta, tan theta is equal to the opposite O divided by the adjacent. With all this, we will now look at this shape to see which one are we given and which of this formula do we need to find the height h here. We have an angle theta is given, and we have the opposite side is given. We are not required to find the hypotenuse. We are only looking for the height. We do not need this that has the hypotenuse. We are not interested in it. We do not need this that has the hypotenuse because we are not interested in it. We only need tan that has opposite and adjacent. We are required to find just the adjacent. So we use tan theta to find this, which is opposite over adjacent. So our tan theta, where theta is 15 degrees, tan 15 degrees is equal to the opposite side is 6 divided by h. If we multiply both sides by h, we have tan 15 degrees multiplied by h equal to 6 multiplied by h over h. Here, the h will cancel out, and we'll have just tan 15 degrees multiplied by h equal to 6. Now, in order to isolate this h to be on its own, we'll divide both sides by tan 15 degrees. This will now give us tan 15 degrees multiplied by h divided by tan 15 degrees equal to 6 divided by tan 15 degrees. Tan 15 will cancel tan 15, leaving us with just h. So this will now be the height h equal to 6 divided by tan 15 degrees. H will now be 6 divided by tan 15 is 0.267949. When we divide 6 by tan 15, the value we got as tan 15, that is 0.267949. We'll have approximately that our height h is equal to 22.39. So this is our height. Now that we now have the height, let's put it into the original triangle that we have. This will now make our height to be equal to 22.39. Remember the formula for our area, which is area equal to 1/2 multiplied by the base multiplied by the height. Area will now be 1/2 multiplied by the base, which is 12, multiplied by the height that we have gotten as 22.39. This is multiplication. Wherever we start, the order does not matter. So if we multiply 1/2 and 12, we'll have 6, because 12 divided by 2 is 6, multiplied by 22.39. If we multiply these two things together, we have 134.35. Our area will now be 134.35 square units. And this is our answer. If you understood what we did, I would like you to try this. If you are given the base to be 30 units and you are given the angle to be 45 degrees, find the area. So you can try this and give me your answer in the comment section. Remember to click on the like button if you like this video. Click on the notification button to know when our next lesson drops, and kindly subscribe to this channel to be part of this our community. Thank you for watching.